So this is a hard question, and I'll start with the expression for the sum. And we know that sum for an arithmetic progression is the average of the first and the last term times the number of terms. So from this, if I factor out an n, we see that this piece, a1 plus a sub n, this is the first term of the arithmetic progression, this is the nth, must equal 1 plus 2n. So I'll rewrite this, multiply by 2, 2 plus 4n. Now these nth term is a1 plus n minus 1 times the common difference. So what I'll try to do is to put this in the same format as that. And what I'll do is to, instead of n, I want n minus 1 here. And that means I need to add a 4. So I'm trying to match these two. So that becomes 6 plus 4 times n minus 1. This is 2a1 plus n minus 1 times d. And you'll note from this that d is 4, and then a1 is 3. And that means that the nth term here is 3 plus 4 times n minus 1. And I can rewrite this as 4n minus 1. Now the condition is that the nth term is divisible by 9, which means this is a multiple of 9. And we need to figure out the least possible value of n. So 4n becomes n 9m plus 1. N is 9m plus 1. M is some integer because it's a multiple of 9. So to figure out the least value of n, I look at the integer values for m. If m is 1, this is not divisible by 4. It's 10 over 4. M is 2. It's 19. Still not divisible by 4. 3. It's 27 plus 1, 28, which is indeed divisible by 4. And in that case, n turns out to be the 7. So the smallest possible value of n is 7. So this is one way to do it. This is how I did it. The second approach is that if you're given the sum, then this is the sum of the first n terms, and then sum of the n minus 1 terms would be, you just replace n minus 1 with n minus 1s. And we know that the Sn of n terms would be the sum of n minus 1 terms plus the nth term. So that way we'll get an expression for the nth term. So we're just looking for the difference here. So we're subtracting those two, n, and I'll subtract them correspondingly, that minus that, plus 2 n square minus n minus 1 square. This is not a square because I'm just subtracting that. And so that becomes 1. This is my difference of squares, n plus n minus 1 times n minus 1, which would again become 1. So I end up with 1 plus 2n minus 1, 4n minus 2, and I eventually get the form for the nth term. And from there, it's similar to what I did here in terms of what the least value of n needs to be. So this is a hard question. I might skip this question if I'm not able to immediately kind of make progress here. So, but the answer here is C.